Our cosmic neighborhood, the Milky Way, is part of a vast and intricate universe, with the Andromeda Galaxy being the closest major galaxy to us. It's estimated that there are about 100 billion galaxies in the observable universe. Andromeda has played a crucial role in shaping our understanding of the cosmos and our place within it. While the Milky Way is our home galaxy, Andromeda stands as a nearby cosmic neighbor. This revelation has reshaped our perspective, dispelling the long-held belief that the Milky Way was the only galaxy in existence, and introducing the idea that we are only a small part of a much larger universe. Our knowledge of Andromeda has greatly expanded over the last century, primarily through observations made on Earth. However, with advanced tools like the James Webb Space Telescope, JWST, now at our disposal, our view has changed dramatically. Recent data from the JWST has challenged previous assumptions about Andromeda, presenting new cosmic mysteries for researchers to solve. The telescope has even detected unusual signals from this neighboring galaxy, leaving the scientific community puzzled. Join us as we delve into how the JWST uncovered a perplexing signal from Andromeda. Throughout history, our view of the Milky Way has evolved alongside our expanding understanding of the universe. In ancient times, the Milky Way appeared as a faint, hazy band of light across the night sky, inspiring various interpretations and myths. It was often regarded as a mystical and central feature in the cosmologies of different cultures. In the 1920s, American astronomer Edwin Hubble made a groundbreaking discovery using the 100-inch Hooker telescope at Mount Wilson Observatory. Hubble's observations revealed that distant nebulae, previously thought to be part of the Milky Way, were actually separate galaxies, each containing billions of stars. One of the closest of these galaxies was Andromeda, also known as M31. Andromeda has a rich history of observations dating back centuries. The earliest known record of the galaxy dates to the 10th century, when the Persian astronomer Abdul Alman Alui described it as a small cloud in the night sky. This was significant because Alui identified the distant object without the aid of telescopes, relying solely on his keen eyesight and observations. Later, in 1612, Simon Marius provided a more detailed description of Andromeda based on telescopic observations. His work laid the foundation for future astronomers to study this massive cosmic structure. In 1764, the renowned French astronomer Charles Messier catalogued Andromeda as M31 in his famous Messier catalogue, though he mistakenly credited Marius with its discovery, unaware of Alui's earlier work. For nearly a century, astronomers struggled to learn more about this enigmatic galaxy, with each generation building on the discoveries of the last. Before this, Italian astronomer Galileo Galilei had already changed how we understood the Milky Way in the early 17th century. Using his newly developed telescope, Galileo made key observations that challenged the prevailing Aristotelian cosmology. He found that the Milky Way was not just a diffuse light band but a vast collection of individual stars, planets, and other celestial objects. His observations demonstrated that the Milky Way was not at the center of the universe, as previously believed, but rather a massive cluster of stars scattered across space. In 1750, English astronomer Thomas Wright proposed a new theory about the structure of the Milky Way in his work, An Original Theory or New Hypothesis of the Universe. Wright suggested that the Milky Way was not an arbitrary distribution of stars, but a flat disk-like structure, and he also proposed that our solar system was located within this vast arrangement. While Wright's theory marked an important step forward in understanding the structure of the Milky Way, it was still limited by the observational technology available at the time, and astronomers continued to believe that the Milky Way was the only galaxy in existence. A major breakthrough in understanding Andromeda occurred in 1864 when British astronomer William Huggins made a remarkable observation. He studied the spectrum of Andromeda and found it was distinct from that of a typical nebula. This discovery paved the way for the world to understand Andromeda as what it truly was: a galaxy, not just a nebula. Today, Andromeda is known to have a mass estimated to be between 1 and 2 trillion times that of our Sun, making it an enormous cosmic structure that just so happens to be relatively close to us in the vast expanse of space. Researchers have long believed that Andromeda is much older than the Milky Way, with an age of around 10 billion years, indicating a long and complex history of formation and evolution. One of the intriguing aspects of Andromeda's origins is the theory that it was formed through the merger of several smaller protogalaxies. This suggests that over billions of years, smaller cosmic entities gradually came together under the influence of gravity to form the massive Andromeda galaxy we see today. Such cosmic mergers are common events in the universe, shaping the evolution and structure of galaxies over time. Astronomers once believed that Andromeda was much larger than the Milky Way, a misconception easily made due to our vantage point from within our own galaxy. Seeing Andromeda from Earth, it appears vast and looming, leading to the assumption that it could not possibly be smaller than the Milky Way. However, this idea has been reconsidered. Recent findings have led to a reassessment of Andromeda's size and mass. New research indicates that the Milky Way might actually be more massive than previously thought, and the two galaxies might be much closer in size than originally believed. The Andromeda galaxy's dimensions, however, are well established. It is known to extend much farther than the Milky Way, with a remarkable diameter of about 220,000 light-years. This far exceeds the Milky Way's estimated diameter, which ranges from 100,000 to 175,000 light-years, making Andromeda a truly massive cosmic entity occupying a vast region of space. This revised view also highlights the complexities and challenges of accurately measuring the mass of galaxies, especially in the core of Andromeda, where advanced observational methods are required to get precise measurements. A supermassive black hole at the center of a galaxy exerts an incredibly strong gravitational pull on nearby stars. As these stars orbit the black hole, their paths curve, similar to the way planets orbit the Sun in our solar system. At certain points in their orbits, the stars come closest to the black hole, a region known as the perihelion. At this closest approach, the gravitational forces are strongest, causing the stars to move at their highest velocities. This intense gravitational interaction causes the stars to bunch up, becoming more concentrated around the black hole, and as they do so, they emit vast amounts of energy, including visible light and other forms of electromagnetic radiation. This increased concentration of stars and the emission of radiation contribute to the brighter appearance of active galactic nuclei, AGN, which are the intensely energetic centers of galaxies. These regions are characterized by powerful emissions across various wavelengths, from radio waves to X-rays, driven by the supermassive black hole at the galaxy's core. Supermassive black holes are incredibly dense objects, with vast amounts of mass packed into a small volume. When astronomers observe AGNs using advanced telescopes like the Hubble Space Telescope, they often notice a unique feature: a distinct double concentration of radiation in the center of the galaxy. In the case of the Andromeda galaxy, one of its most intriguing characteristics is the presence of 2 points of brightness, each representing areas of higher radiation emissions, one of which is located slightly off-center. At the heart of this brighter concentration lies a supermassive black hole with a mass estimated to be between 11 and 23 million times that of the Sun. Such supermassive black holes are believed to be common in the centers of galaxies, playing a critical role in the formation and evolution of galaxies. When matter, such as gas and stars, gets too close to a supermassive black hole, it forms an accretion disk. This disk of swirling material heats up as it is pulled toward the black hole, generating intense radiation across different wavelengths. This is why AGNs are so luminous. As astronomers observe the AGN of Andromeda, they note a brighter concentration near the central black hole, resulting from the unique gravitational interactions between the black hole and the surrounding stars. Andromeda also has another fascinating feature: a large number of globular clusters. These are tightly packed groups of stars that orbit around the galaxy's center, much like satellites orbiting a planet. Andromeda is believed to have around 460 of these ancient clusters, each containing thousands to millions of stars. The presence of so many globular clusters provides valuable insights into Andromeda's history and interactions with smaller galaxies over billions of years. It suggests that Andromeda has been a dynamic galaxy, absorbing smaller galaxies in a process known as galactic cannibalism. As smaller galaxies approach Andromeda, its gravitational forces strip them of stars and other material, which are then incorporated into Andromeda's stellar population, enriching its star system. This tendency for Andromeda to accumulate stars from smaller galaxies is typical of spiral galaxies, which are known for their distinctive disc-like shape with winding arms. These galaxies offer an ideal environment for interactions and mergers with smaller galactic companions. In addition to its other remarkable features, recent observations have sparked a theory that Andromeda may be undergoing a fascinating transformation. It appears to be evolving from a typical spiral galaxy into a more unusual type known as a ring galaxy. Ring galaxies are intriguing objects characterized by their circular or ring-like structure, composed of bright young blue stars. The center of a ring galaxy contains relatively little luminous matter. This unusual configuration makes ring galaxies stand out among the variety of galactic structures. There are three primary types of optical ring features: nuclear rings, inner rings, and outer rings, each located at different distances from the galaxy's center. Ring galaxies can form in two primary ways: through the collision of two or more galaxies, or by a smaller galaxy passing through the center of a larger galaxy, triggering the creation of a ring-like structure. Some examples of galaxies formed through cosmic collisions include the Cartwheel Galaxy, PM 2026-424, and ARP 147. However, creating a ring galaxy is not a simple process. It involves complex interactions. Currently, there is an even more intriguing development underway. The Milky Way and Andromeda galaxies are on a collision course. Eventually, they will merge to form a new supergalaxy. This cosmic event has already been given playful names like Milkomeda. While these names might sound exciting, the consequences of such a merger for humanity could be catastrophic. The collision could trigger bursts of star formation in areas where gas clouds collide and compress, creating new stellar nurseries. These regions would be the birthplace of massive new stars, and the night sky would become a spectacular light show, with displays of star clusters, shock waves, and intense bursts of radiation. In the aftermath of this stellar merger, the entire sky would change dramatically, with new star clusters and celestial formations altering the cosmic landscape. However, despite the breathtaking beauty of this celestial event, deeper consequences would follow. If life were to emerge in the newly formed galaxy, it would likely undergo a dramatic transformation due to the unique conditions of the new environment. The physical and chemical properties of the merged galaxy could lead to the development of life forms very different from anything we know on Earth. Unfortunately, humans would not be able to survive in this new cosmic era.